Everybody is ready to start the class? So in previous class we have been completed our first step of what we expected in our law, that is based on ideal models we have completed, correct? Based on diode models. In that variety of models we have completed, one of the best topic to for the coming sessions it will be very comfortable and easy to understand if you know these models clearly. One is ideal diode model, and second we have seen is CVD model, that is constant voltage drop model, and after that we have seen PWL model, okay, piecewise linear model analysis. After that exponential models technique we have seen, and finally we have been completed small signal model. I'm expecting these concepts are okay. Now it became easy to understand this concept for you. Today class we are starting a new journey. That is your step 2 in analog electronics based on certain modules like clippers. Today class, maybe today entire class will take clippers because our schedule is from 8 to 12:30. Total discussion will be on clippers today. Tomorrow class I'll complete the other 3 modules. Small modules are there: peak detectors, clampers, and voltage multipliers. That is tomorrow's session. These two days we are going to spend the time for these 4 modules. After that, one more day we'll spend some time for 2 hours to do the workbook problems based on this step 2 analysis. That is our plan. So by short circuit method. Okay, that's question number 14. I'll explain at the end of the class, don't worry. Okay. Yesterday, electrical, I have given one question for you, question number 14. Multi-diode concepts. I think some students may get that answer, some students may not get. We'll try it one time. T2 question, Samresh, T2 question is actually an easy 38th question, I think. We already solved that question. 38th question is your T2 question in this workbook. So that question I already solved it. Just want to verify that question. That is your small signal model problem, we have done it. Using some capacitor parallel to dynamic resistance. That question for you, please try to see that one time. So let us start our new journey today. Clippers is our today class. Okay. Today our schedule is, I thought yesterday my timing is afternoon. Okay. It is became reverse now. Morning is analog now. Afternoon is digital. Automatically they have been changed the schedule. So according to that we'll go now. So let us start clipper techniques. Keep the heading. One of the typical concepts in analog electronics. We'll make it easy. We'll try to make it easy now with some techniques. So keep the heading clippers. Keep the heading clippers. So first of all, what is the meaning of a clipper? Okay. Why we are using clippers? Just tell you the idea. See the definition of a clipper. Clipper. Write on the definition in your notes. Clipper is a circuit which will eliminate a part of the input signal. This is a very simple definition I have written. Clipper is a circuit, write on your notes. Clipper is a circuit which will eliminate a part of the input signal. That means the main job of using clippers is it want to eliminate some part of the input signal. That design we call it as clippers. So please note on it. Clipper is a circuit which will eliminate a part of the input signal. Okay. For example, for understanding purpose, for example, I'm taking, if I give a signal like this, sinusoidal signal, if I send a signal to a clipper circuit today, this is your clipper circuit. So what is the response we are expecting is, maybe you may get like this. This is your signal. This is your signal output. But we are not expecting the total input what we are giving as an output. It's telling that some part of the signal will be eliminated. For example, I can send this signal up to here, like this. So the remaining part, whatever you are seeing here, this remaining part, this part is getting clipped off. Clipped off means it is eliminated from the output. So this knowledge we call it as clipping circuits. One of the important application most of the times we use in analog communication field, because whenever you transmit a signal, it will have some noise. So when the noise is there, because you are transmitting from transmitter to receiver, it has to travel for a long distance. In between in the channel you will get some noise. That noise should be eliminated. That noise, if you want to eliminate at the receiver side, we have to design the clipper circuit. The clipper will eliminate that noise. Maybe this is a noise for you, and remaining signal it will try to transmit and it will try to receive. It will get received by the receiver. That trick is called as clipper circuit. So what is the application is? It will be used as a noise elimination circuit. We can write. It is used as a noise elimination circuit. Wherever you get noise in the signal, it just eliminate it. Noise elimination circuit we can call. So this is your application using clippers. So clipper is a circuit which will eliminate, means we are just eliminating the noise inside the signal. The remaining whatever the information we have without noise, we'll try to transmit it to the receiver. Okay? Yeah, it is 35th question, easy. That is your T2 question here, so don't get confused. Okay? That already I discussed in previous class. So please complete, this is about the clipper concept today. So what are the clipper models we have to discuss today class? Is our analysis. See. What are the clipper models? We can do it. Just type I'm writing. Clipper models. So we are going to discuss certain models to get the subject knowledge. That is called, first one, shunt clipper we are going to start. This is our first today class journey. We are going to understand how to design shunt clippers. Is our first idea today. Okay. Today is completely circuit design analysis. Nothing theory, nothing is there. Try to understand how we can analyze it. After that, we will try to go for series clipper designs. We try to discuss all the things. First one is shunt clippers. We'll discuss. Then how to make a series clippers. Okay. Basically, we have only 2 types of clippers: so shunt and series. With respect to shunt and series, we can do some extra models. That is topic number 3. Two independent level clipper we can do. 2 independent level clipper. The name itself, it is telling that the both sides you can clip. Positive side of the signal, negative side of the signal you can clip. It will not only clip the positive. It will not only clip the positive. It is only an example I have taken. Wherever you have noise, suppose noise is here, we can clip that part. If the noise is in the middle, we can clip it. So variety of models we have that we are going to understand with a series of topics. Clipping means anything we can clip. You have part of the signal. Okay. The talent how to get is the design part. Don't restrict that clipping should be only to the positive side. I can clip to negative side because noise cannot tell that I will get always in positive side. Noise can come anywhere. Unpredictable. Correct. So for every concept we should have a design for that. So fourth one, point number 4. Output following clipper circuits. Input clippers. So what do you mean by output following input clipper is, suppose the noise is coming in the middle of your signal. That is above zero some noise is there, below zero some noise is there. If you want to eliminate that type of noise, we have some technique called as output following input clippers. It will just eliminate the middle noise. Okay, that's a special design. Clear? Like this we have different ideas. The last one, a peculiar idea. Clipper with attenuator. With attenuator. So this is our course today in analog electronics. Step by step how to understand all these models. If you can get this knowledge, irregularly they ask you the question also, there will be some basics behind this from these fundamentals. Okay? From these fundamentals, we'll apply that knowledge to any circuit given in the clipper. Because clipper, anybody can design whatever they want. Okay? For any circuit, we can get some clipping actions. Okay? For that case, these are the principles first we have to understand to do any new problems in the subject. That's why first we'll slightly understand. First we'll understand carefully each and every step of these models. Then we can undergo to the exam questions. Okay? Whatever may be assignment questions, all these things. Yes, Rahman, some data will be removed, but the data is a noise. Okay? That noise is nothing but your data, which I don't want to the receiver. We can eliminate it. This is the first slide, Aditya. Good morning. This is the first slide. So please copy up to here. We can start the class from here today. Please complete up to here. Who has came late? Please, this is the first slide today. Clippers I am teaching today class for you. Clippers. So definition I have written, example I have given, and what topics today we have to complete. Clearly I mentioned in the first slide. So it's a very comfortable topic. You'll enjoy it in the class. Let's see what technique I'll use to develop this concept. I'm going to create one beautiful technique for you that will help the student to answer this type of questions very easily. A new technique I'll explain. Who is this? Good morning to everybody. Good morning. So let us start today our journey. Let us start our first journey today. Keep the heading. First topic today is shunt clippers. Shunt clippers. Shunt clippers we have nearly 6 models we can study inside the shunt. We have 6 models. We'll try to understand each model how to develop the concept. Okay, shunt means nearly 6 designs we can do in shunt clippers. Let us see what are the shunt clippers we can do. Okay. See the model 1 I'm doing analysis today. Model 1. Model 1. Shunt means why it got the name shunt here is try to see the design. A series resistor R I have taken diode with a ground reference. This is diode, this is your output, this is your input. Assume that for all these problems you consider diode is ideal for study purpose. Okay? Practically how to do, we'll see at the end of the class. Just ideally how to do all these questions, first we'll try to practice it. Okay? Okay. Okay. Kumar, I think 5 modules are there. Try again. What do you mean by try again? Take this diagram, whatever you miss you can see in the slide recording video. So this is your first diagram, you're seeing shunt clipper we are calling. Why this is called shunt clipper? Correctly observe it. Whenever you keep the diode in shunt to the input signal, it is called shunt clippers. That means this diode not only here, we can place this diode here, resistor here, we can move the components. So for any clipper circuit, we require only 2 components minimum. One is a resistor, one is a diode. Diodes can be 2 diodes, you can take 5 diodes, you can take resistors if you want, you can take 2 resistors, 5 resistors. But the minimum components required is 1 resistor, 1 diode to make a clipper circuit. So I kept my diode in shunt. Okay. Okay, Manoj, don't worry about that. Because of the schedules, you change your MIs. There is some reason for that. Because of the scheduling about this digital code. In Hyderabad, we have only 2 digital codes. Okay. So after this class, some other teacher has to take. That's why schedule has been reversed. Okay. Don't worry about that. Because we have to manage the schedules, correct? Here, not only I am teaching, some other teacher is teaching after that. So don't worry about that here. Anyway, you have some 8 to 9 hours class per day. Okay. Don't bother about all these issues. So this is your circuit. Shunt, I think you got a feeling. The diode has to be kept in parallel to this input signal is called shunt clipper. Okay. Das is asking why if I use only diode, I think that is wrong here. If I use only diode without resistor, the circuits will not work. Why? Because the diode parallel you are keeping, correct? Suppose if my signal is crossing the cutting voltage of the diode, it is represented as a battery. Now your signal is parallel to a battery, that is not possible. That's why for any electronic circuit, resistor is minimum. You have to connect in series to the diode. Okay? Otherwise, that will not be a correct circuit in our electronics. Compulsory resistance is required. That's why they started the idea like that. Now you are seeing here, when the input signal is a sinusoidal, it is looking this diode in shunt. This is shunt. You kept the diode in shunt. That's why it is called as a shunt clipper in class. And one more point observation you have to do is this cathode side, there is some fixed value we kept called ground, which we call it as a reference. We call reference is 0 volts. So these are the 2 points you have to clarify in the clippers. What reference he has given? Because signal is not the reference. Signal is a dynamic signal. But other side somewhere you have some batteries, maybe grounds, whatever maybe. These are called as fixed values. A ground can be treated as a 0 volts, which we have taken as a reference for the diode, so that we can compare your signal with respect to the reference. That basic ideas first you must get seeing the diagram. So then what is my approach today? What technique I'm going to use to make these problems very comfortable and simple? Generally in this what we have to find is, okay, they'll ask in the exam 2 questions for you. Draw the transfer characteristics. Draw the transfer characteristics. Draw the transfer characteristics and output waveform. So mainly this you have to understand. How to draw a transfer characteristic for the circuit and how to write the output waveform for the circuit. Mainly the concept is based on these 2 topics. Exams, they'll ask you, please show me the transfer characteristic for any clipper circuit. Transfer characteristics is nothing but output voltage to input voltage, how to draw a graph is called transfer characteristics. So how output is behaving with your input voltage, we call it as transfer characteristics. Not only that, sometimes in the options they'll use some output waveforms also. At that time we have to show how the waveform will come at the output. Today is our job on this. But what are the methods we can use to solve this problem? First I'll give the confirmation for you. We have 3 methods actually we can do. Testing. We can have 3 methods actually to solve this problem. 3 methods. 3 methods we can do. The most popular method is open circuit test we can do. This is one popular method. Second, we can go for a short circuit test. But today I'm going to explain one special trick. That is one more trick we can do is breakpoint method. So there are three different techniques. Some teacher will use to teach an open circuit test. I think the maximum teachers will teach in open circuit test. Okay, I've seen so many teachers are teaching an open circuit test. But short circuit test most of the times will not use. It is an inconvenience for doing clipper problems. Okay, current wise you have to calculate. Voltage wise is easier generally in clippers compared to current calculations. That's why short circuit test generally most of the times maximum people will not touch. Open circuit test they'll show interest. But there is one more special trick which have been created for you, which is called breakpoint technique. We call this as. That is most easiest, and I think for that mind is not required much. But for open circuit test we have to think logically and you have to solve the problem. So what I'm doing in this class is I don't want to make complex this subject. So I don't want to use this test. I don't want to use this test. I'll use this test. That is called breakpoint technique. I'll explain, which will give a convenience for the student. For any question he will solve very comfortably. Much thinking is not required. So that's why I'll try to propose for you this method called as breakpoint method. We call. So for any clipper circuits in my class, apply the knowledge called breakpoint method and solve the questions. Today you'll understand how the breakpoint method can be applied for all the circuits. You'll understand the trick now. Okay. Okay. So nothing is there. Just a reference I have said is 0 volts. Diode is ideal. The diode is connected in shunt. We call it as shunt concept. So we are going to highlight this method to teach the clippers today. One of the easiest and quick coming concept. So this method I'll try to explain. I'm not interested to explain each and every method. If I explain like that, you'll get confused. So each method don't read. Only one method will follow all the students. Okay, in my class. That method is one of the simplest method I can say. Breakpoint method. Let us apply the technique. What is breakpoint method? I'll explain you. For this question, how to do the breakpoint method. Okay, what is the meaning of breakpoint? How to start any circuit? We'll see the trick for that. Okay, so let us apply breakpoint method. So I'll take in the next slide to do this analysis. Copy up to here. Firstly, I'll take the diagram once again to start breakpoint method. So short circuit also we can do, open circuit also we can do, like our DC analysis we have done. But in this we will use just a different idea model called as breakpoint method we use. So that it will be a unique model for doing each and every question very easily. For any student it looks comfortable. Okay. So let us do in a fresh page. Fresh page. So I'm taking the same circuit again. This is your resistor R, VI. We have a diode with a ground. This is diode. This is your V0. This is the model we have. What is breakpoint method? Try to see. What is the meaning of breakpoint method? Means start with the scale marking like this. Analysis I'm doing. Analysis. Start with an analysis like this, saying that you draw one scale mark like this to start these clippers. Okay. The scale mark why I have written is what are the references given in the problem. First I'll make in the scale marking. If you see in this circuit we have only one reference called as ground. Let us keep that ground here as a scale marking point. This is ground. So somewhere here it is 0. So below 0 we have up to minus infinite values we can apply. Above 0 we can apply plus infinite values. Anything can be happens. This is called scale marking we can say. In the exam I think sometimes in the circuit we have 0 reference. Sometimes 2 volts battery also they can view. Sometimes minus 2 they can view. So references can change. So in this problem 0 is reference. That's why I have started with a 0 reference in the class. That's very easy to write. Okay. So I think I'm giving a perfect time to copy. I think you are becoming very slow. Please make it fast. I'm giving a very good time to write like this. Why I'm writing like this means parallel you will also write like this. Okay. Don't expect me to go very slow. If I go very slow I think subject will not be covered. So I'm making very slow for you in the class. So from here to here we have a reference 0. First you mark that point. After making that marking you have to understand this diode can be on, can be off. Correct? How many situations we can see? If I have a signal here, you're applying a sinusoidal signal. Having 0 is the DC. Can I expect your signal can go above 0, can go below 0. That is the point we are seeing. Signal can be above, signal can be below. I understood that diode can have two status now. It can be on or it can be off. So these are the 2 points first you justify your concept. So below 0, above 0 you write, seeing the board, saying that we can write the diode status, diode D status. We have 2 possibilities we write. Diode D status possibilities I'm writing. Possibilities. Okay. One is diode off, diode on, one case. Second case, diode it is off. So these are the points I understood seeing the diagram. Diode can be on or diode can be off. But don't write anything here because sometimes the references can change by using this audience 18 meters, all these things. This point is correct or wrong, we'll justify in the graph. Just for rough sake, first you have to write the reference. And I understand that the 2 positions are happening on or off. Okay, greater than what happens, all these things also don't think. Diode can be on or off because we have 2 positions here. Positive cycle, negative cycle. So these points you confirm first. So there are 2 status I understood. In the circuit, diode can be on in some time, diode can be off in some time. With these 2 steps, you write 2 concepts now. When diode is on, you start designing the circuit. You estimate that when diode is on, what happens? When diode is on, just you take the circuit. This is R, ideal diode, so you can take it as a short circuit. This is your output, this is your input. Can I say short means the output will be 0. This is the first step I got. When diode is on, maybe your circuit will behave like this. Okay, this is only approximation sample. That the diode is on, it will be short circuit. Okay, then output will be 0. Another point we have is diode is off we have, second case. This chance is also there. So chances I'm writing. This is R, this is VI, we have open to ground. When it is off, ideally we take it as open. So output is equal to input we are getting. So we got 2 circuits like this. So this is the thing you have to do. Estimate that diode can have how many chances. On and off. 2 chances will be there for single diode. So the chances you write that. Diode on and diode off. Okay, diode is on and diode is off. So with the help of this, what you can do? So 2 positions we got, 2 results we got. He is asking you transfer characteristics, please draw it. I got some results now. With the help of this, how a transfer characteristics, I'll draw. See the simple concept. If this is your graph side by, this is your VI and this is your V0. Whenever you draw a graph between output voltage to input voltage, we call that as a transfer characteristics. This is called as transfer characteristics we call. We call this as transfer characteristics. Nothing to do. These two equations you produce in the graph. Okay, these are called as the straight line equations. One is output equal to zero line. One is output equal to input line. How to draw these two lines? You just observe it. One is output equal to zero line is this one. This is one line. Output equal to zero line. Okay, so zero means output on the x-axis you can write. And one more line is there here. Output equal to input. This line is nothing but a line passing through origin. So this is the way you can write output equal to input. Have you seen that the two results as given two straight lines? One straight line is horizontal we are getting. One straight line is an inclined line. So based on these two lines, can you see there is some intersection between these two lines? We got some intersection at the origin point. This only we call it as zero, which is called as, we call this point as break point, we call break point. So in between two results, we are getting some intersection point that we call in the classes break point. Yes, this is break point method. So this is called break point. So you will get two straight line results, which is somewhere it will intersect that point. That intersection point we call it as break point. What is the advantage of understanding break point is, below this break point, the switch can be on or off. Above the break point, the switch can be on or off. Possibilities are there. So that point will decide, okay, the characteristics of the graph can change. So below something is happening, switch is working in one manner, above the switch is working in another manner. That will decide by that intersection point called as break point. Therefore, it will be very convenient now. For single diode problems, it's very easy. Just one diode means on off, you can write normally, and just find out these lines and just find out the intersection point. Now the point is, finally what you have to do is an observation we have to do. An observation I'm doing. What is the observation? Zero is confirmed here. So below zero, if you see, the signal is going towards the anode side, and cathode side is zero. Just apply the knowledge. Anode is positive, cathode is zero. Means positive cycle if you apply this side. This is positive cycle. You're applying here. Can I say that diode is getting on for this? Because in this case, anode is greater than cathode we are seeing. So whenever anode side you are giving positive signal, reference is zero. You're crossing zero means diode is getting on. Seeing this diagram, you can say diode is on. So we confirm that above zero diode will be on. And when you come to below negative cycle, this is your negative cycle. VA is less than VK is coming, so diode will get off. So this is an observation I have done. First I have not observed. After finding the break point, I confirm that my break point is correct only. After that I come back and I'll see the comparison of your diode. By using anode cathode positions, easily a student can check the position. When the diode will be on, when the diode will be off. Completed the concept. This is a very quick method I can say. Now can you see that when diode is on, you're telling in positive cycle diode is on. But which line it is satisfying is output equal to zero line it is satisfying. Okay. Output equal to zero line it is satisfying. So shall we take this portion above zero, you're getting output equal to zero here. Because at this position your diode is on. So this line it is following above the break point. Okay. Below the break point, your diode is off. It is following this equation, which is this one, this equation. This is your output equal to input line. It is following. So just you can write this one. Diode is off. So can you see the blue ink, whatever I have written with blue color, that is your transfer characteristics. So that is the simplest way of writing the transfer characteristics. Arnab, I think the schedule time has been changed here. Morning 8 to 12:30 is analog class. 1:30 to 7:30 is a digital class now. It has been reversed for 2 or 3 days. After that, the schedule will come for you. So please, sorry for the inconvenience. Morning is analog class. Afternoon, whatever the schedule you have given, it is reversed actual. Okay, please try to understand it. So some students, I think message has not came. Sorry for that. So morning class is analog. Afternoon class will be digital, my friend. Okay. So this is our clearance here. So we got a diode off, diode on positions. When diode is on, output is equal to zero line you follow. When diode is off, you follow the output equal to input line. This line. Okay. With this, we have been completed the transfer characteristics. Now how to write the output waveform? You can see output waveform. This is your output waveform with respect to omega t. With respect to omega t, if you see V0 versus omega t, can I say that your waveform is like this? Input waveform is in this manner. So according to the transfer characteristics, what is the information I got is, for positive cycle, I think it is not giving any response. But negative cycle, whatever you are giving, that is coming here. Therefore, in this position, your output is zero is coming. In negative cycle, output and input are coming same. This is the information it has given. So for positive cycle, you write just a zero. So no response. So that means the signal has been clipped off. Below output is equal to input means whatever you are giving, that is coming to the receiver. So this is the way how you can write a waveform from the transfer characteristics. So with the help of transfer, we can write the output waveform. Okay. So that's nothing is there. Graph is very simple. First, these two equations you have to confirm. Just on and off, you take two possibilities because the diode can be on and off. Only two possibilities per signal. These two possibilities wise, you write two lines, straight lines you draw. Output equal to input line, which is passing through horizon, and one line is horizontal line. Okay. After that, estimate using the diode position when it will be on, when it will be off. You estimate it like this. Above zero, below zero. You compare with the anode cathode. Just visualize it and say that when it will be on, when it will be off. So with the help of this, below it is off, above it is on. I got. When it is on, this is the result. So that line I have drawn. When it is off, this is the result. So that line I followed. So two different lines are coming because at two different positions the lines are different. Okay. So this is called concept. The one of the easiest concept it is. Now onwards, it will become a hobby for you to do all these lines. Yes, for horizontal line, diode is off. Correct. Yes, Snehal Kumari perfectly said. Horizontal line, whenever you see like this, it means okay, the output is not responding with respect to input. It's called Clipper circuit. So please note on it. The same thing we'll do for every question like this. It will become a hobby for you. So I have seen that how much quick method it is. So breakpoint method, I'm expecting one of the easiest method for the student to understand in analog electronics. So we all follow this method. So similarly, we'll do every questions like this and we'll enjoy the problems now. So that this topic will not become tough for you in the exam point of view. If it is a single diode, always remember diode can be on, diode can be off for AC signals. Every time it is not required to write like this. Okay. Diode can be on, diode can be off. These two positions are interesting here. And the last graph is nothing but when it is on, you are seeing here here I made it as 0 for positive cycle. Above 0 means positive cycle, it is 0. Below cycle means output is equal to input. Output is equal to input I have written. Seeing the transfer characteristics. Yes, breakpoint is just to confirm whether my reference, whatever I have taken is correct or wrong. Okay, this breakpoint will tell in the graph. Correctly it will decide. Because in sometimes reference voltage, whatever I write, seeing the board, sometimes it can change. Using 18 meter circuits will come in the next point. At that time it can change. That's why generally we take reference point first roughly and we'll estimate it and we'll find out the breakpoint, then we'll confirm it. Okay, this is the story. Initially don't confirm it. Take the reference first and analyze it and see the answer. An output waveform y take on horizontal line. Ujjwal Kumar, I think horizontal line, whatever you're taking, this is 0 we have taken, correct? Because the response is 0 here. And below you are getting output equal to input. That's why at 0 position we have written the horizontal line. So now onwards these questions, you can do it comfortably yourself. Let us start doing the other models. First model is completed. So please complete it. We'll go for the second model now. Like the 6 models will complete. So Nikita Raj is asking, is it positive clipper? If you say this is a clipping is going in positive, correct? This is a positive. Positive is clipped off. That's why it is called positive clipper. If the clipping is going in negative side, we call it as negative clippers. Okay? So no need of mentioning that name positive, negative clippers. By seeing the board, you can say it's a positive clipper. You are just clipping this part. This part you are clipping. So that's why it is a positive clippers. If you are interested, you can write the name. It will work like a positive clippers. Okay? Great. Yes. So I'm expecting you must be fast in doing now. These problems you have to do fast now. Time waste should not be there. First topic slowly I have explained. Now one by one you copy it. Parallelly I'm doing. So I'm expecting in the next slide you can see model 2. You do it parallelly with me now. It will not take much time. Model 2. Suppose if I take a resistor R, diode with some reference voltage, for example some VR, some voltage I have taken. This is your output. This is input. Now start doing the same problem. Same method applied. If I have only one diode, we know that it will have two status. So you can check with two status. So you start with the diode is suppose on. We have two possibilities. That is resistor R. Diode is ideal you take. Every problem do it in ideal first. Ideal means short with a battery. This is your output. This is your input. The answer is coming to be VR. So when diode is on, I understood that output is VR. Is the first answer. Okay? Output is VR is coming. If diode is off, simply write resistor R. This is VI. Take it open with the battery VR. So output is open means output is input. So these are the two equations I'm getting in this problem. So if both parts are clipped up in A, just only one part we are talking. Single diode means we can keep only one side. First complete this parts. Yes, Radha, we can say that previous topics are called half-wave rectifiers also we can say. This is also whenever reference comes, it will not become rectifiers. If there is no reference, only 0 ground, they will become rectifiers. So rectifiers, clippers can convert into rectifiers. But rectifiers cannot convert into clippers because clippers requires references also. Okay? So we can make rectifiers using these circuits only. There is no confusion about this. We can make rectifiers also in coming class. So this is two equations we got. Let us draw the transfer characteristics simply. This is Vi, this is V0. So we have two lines are there. One line is constant VR line. Maybe this is your VR, output is VR. It's a constant line. Output is equal to VR means constant line. And one more line is there. Output is equal to input, which will pass always through origin, like this. This is output is equal to input. So two equations we have. This is output equal to VR. Can I say the breakpoint? Breakpoint has changed here. The breakpoint came here. This is the breakpoint. At this breakpoint, what is the input we are getting here is, we are getting here VR. So this is your comparison. So I think below VR, something will happen. It can be on or off. Above VR, something will happen. Seeing the diode position easily you can tell. This is your anode. This is your cathode. So any value you apply to the anode, if it is greater than VR, diode will come into on. So I'm expecting above VR. Understood that above VR, diode will be on. Seeing the diode model, we can tell. Okay, below VR, diode will be off. First you write these points. Seeing the diode model, we can understand. Okay, anode is greater than cathode, diode will be on. Anode is less than cathode, diode will be off. When diode is on, I think this is the answer you have to write. So it will follow this graph now. It will follow this graph. This is output equal to VR. When diode is on, it will follow output equal to VR. When diode is off, it will follow this line. It is going to follow this line. So you got the transfer characteristics, output equal to input. So this is where you can simply draw the transfer characteristics. So finally, what is the output waveform? We can write. This is your output waveform. This is 0. We can write the output waveform for this. So Nikita Raj, you should not ask the questions like this. Very simple question here. Here output equal to VR. How it is coming here? This is parallel to this V0 is parallel to VR. So VR is equal to V0 or not? We are keeping a voltage at the final output. Then automatically V0 will become VR. Confusion kya here? Simple things. Okay, don't confuse with that small points. Output is equal to VR. Here it's open, so output is equal to input. At least first you practice that circuits. Okay, the conditions you practice. Then this all becomes easier for you. Okay, very easy actually. Within seconds I'm getting the graphs and outputs here. So what will be the waveform you have to draw is this output equal to input has to follow up to VR. So you take some reference here. You take some reference that is VR. So that below total signal will pass. Below total signal will pass. Above that, whatever the signal you are giving, it is getting a constant line. Whenever a constant line comes in clippers, it is called clipping. So I think this above part is clipped off. Below part it is passing. So you can see above part is clipped off, below part it is passing. There is a reference called VR. So that means if the noise is above the reference voltage VR, we can eliminate the noise like this. Okay, this is also called positive clipper only. Okay, so I'm expecting second model is also completed. You can just note down these models. So आज class to write fast so that I can complete all the models for you. Don't take much time to write. I'll just give one minute for you to copy it. Next model I'll start again. This is the clipping part you have. This is the clipping part. It is also called positive clipper with some reference VR. With reference VR. It's a positive clipper with reference VR. We have designed it. So we'll see like that model 3 how to do it. This model 2 is completed. You do it like this. You're gonna do it yourself. Model 3. Thus, I think you should not confuse about output waveform because it's very clear seeing from the board I'm writing it. Can you see that VR, you just write down some value here. VR means what? Some positive voltage. It is not mentioned. I've taken some limit there. Below this limit, VR, this total signal is following whatever the input you are giving, that is coming as an output. So I'm just following the input equal to output. Below VR. Above VR, I think it is getting clipped off. That means what constant value is coming. You are giving signal, but I'm getting a constant. So the constant I have written here. Constant. Completed. So this graph will give the resemblance of the output waveform. Okay? Very good. Next, to go to the next slide. That is model 3 you can write. Model 3. Model 3. We have a resistor R. This is VI. We have a diode. Can you see that? Now I'm giving some negative voltage. Now the concept is I have given a negative battery in the class because I have 3 chances of giving references: 0 reference, positive reference, negative reference. So now I have given a negative battery. How do you identify as a negative battery? Is first negative, next positive is a negative voltage indication. Now can you do it yourself? This question. I'll wait for 1 minute. You try to start doing it so that your mind will get improved in thinking this type of problems. Every time don't depend on me. First I have given the methodology. Start doing the method. It's not very tough to analyze these topics. Everybody can do it. Just common sense is required, not more than. Try to start doing this problem. Only 2 steps. Diode on, write the model. Diode off, write the model. Get the 2 equations, draw a graph, and finally output waveform. So try to start doing. So meanwhile I'll take some water. Try to start doing it. Children, I'll do it. You just check it one time. Diode is on. It can happen or off. It can happen. So I'm writing first model. When it is on, we have to replace with a short circuit with a negative battery. That is VR. So now the answer is output will become minus VR. So it became now negative battery. Previously it is a positive battery output. This one equation I got, which is a straight line equation. And diode is off if we take. We have a resistance R. This is VI. So open with a negative battery. This is VR. So I think when it is open, no doubt output is equal to input. Because no current is flowing in the circuit, so output is equal to input. 2 equations I got. So let us draw the transfer characteristics side by. This is your VI, this is your V0. I have to draw the transfer characteristic for this. One is V0 equal to minus VR. Maybe it will come in the negative side, this line. This is equal to V0 equal to minus VR. This is minus VR. Negative side we have the line. Okay, this is a constant line in negative side. And output is equal to input line. We already got habituated with this concept. Is output equal to input line, which is passing through origin always. Okay, 45 degrees line. Output equal to input means 45 degrees. So what is the break point? Where you are getting break point here is the break point I have seen here. This is the break point. So these 2 lines are intersecting at that point. So can I have this break point position as here minus VR will become the break point position. So I can understand when the diode is in downward direction. Always remember when you go above this battery, always diode is coming into on. Diode is coming into on. Below this battery, the diode is becoming off. So according to anode cathode, you can see the position. When it will be on, when it will be off. If you cross this voltage, the diode will be on. If you don't cross it, it will be off for you. Whenever it is open circuit, off condition, output is equal to input line you have to write. So I think it will follow this line. Off means it will follow this line. Up to here, it is going to follow this line. Therefore, output is equal to input line will come here. Okay, output is equal to input. The next is output equal to minus VR when diode is on. This total is diode is on, where it is giving this constant line. Output equal to minus VR. So I think this is the transfer characteristics. Okay, based on this is the transfer characteristics. Thank you very much. Yes, you're enjoying this model. Great, great. Yeah, this is one of the easiest model. Everybody can enjoy it. So can I have the output waveform seeing this diagram, seeing this transfer characteristics? How to write a waveform? Seeing this transfer characteristics is this part we are following. Okay, up to minus VR. So you take these lines like this. This is minus VR. This is minus VR. This is the minus VR lines. Okay. Below this you are following. Above that you are not following. So below only you are following this part. Maybe this is your waveform. Below you are following. Above it is a constant of minus VR. The waveform can be written like this. So I'm expecting done sir. Great. Perfect. So who has written correctly? You can leave it off. Who has not written, please see where the mistakes you have done in the problem. So in the coming sessions, it should be a very easy and comfortable topic for papers. So 3 models have been completed. Let us go for next model. If this negative is connected to the cathode, meaning is not always the diode will be off, because we are not giving here a DC, we are giving AC signal. That AC signal can come below this battery, above this battery. We have to check like this and you have to tell the answer. Seeing that minus, you should not say that always the diode will be forward bias. That's a very bad thinking in the electronics. Anode side, you are dynamically changing the value. That value can be below this cathode, above this cathode you are giving. Then how can you say that the diode will be always on? Always on you can say when you give a constant voltage at the anode, but this is signal conditions. Okay, please correct Swati. Yeah, Srivastava, definitely I'll use small break for you. Around 9:30 I'll give the break because I also not taken breakfast. Just I'll give the break at 9:30 like that. Okay, don't worry. At least we'll complete before that. Some more topics will complete. Break will be there. You can take a breakfast, no problem. How you related diode with minus VR? Who is that? Ria. I think this is a reference here. Cathode side we have a reference. With respect to reference, anode is signal we applied. It can be more or less. We're just checking the values. Below the minus VR, diode is getting off. Above this, it is getting on. Seeing the anode cathode positions I'm telling. That first class only you have some hobby about DC analysis. That's why I'm not concentrating much. Greater diode will be on. Anode is greater than cathode. Like that you visualize the circuit. Prashant Kumar, output waveform problem is there for you. It will be rectified. Just if you can think yourself. Always don't think in myself. You think yourself also. Seeing this diagram, you have to feel that output equal to input is coming below minus VR. By seeing this, I'm writing. And above minus VR is a constant. Constant. Now, what is the meaning of explaining that? Okay. VR is not sinusoidal, Swati. VR is not sinusoidal. It's a reference. It's a fixed DC voltage. Great. The next we have is model 4 we are saying. Now you can start doing yourself. It will be easy for you. Suppose if I take a resistor R, this is VI, we have a diode upward I kept with a ground. This is output. Start doing this problem. Treat it as ideal diode. I'll just give 1 minute time for you to do it. After that I'll complete it, that model. Be careful now. Be careful. Diode is upward. Diode is upward means your reference where you connected is at anode you connected. This is cathode. You have to check these positions to tell when the diode will be on, when the diode will be off. You have to tell correctly now. So please start doing it. Whenever it is a single diode, we don't have any objections. It can be on, it can be off. Start doing the problem and see that how the waveform will come for the circuit. Rahman, if you have not understood previous output waveform, present output waveform, please understand. Okay? So that by this problem, previous problem, you can take the help and understand it. Okay? Here also I'll explain you. Next problem also I'll explain the output waveform. Every question I'll explain you. When it will strike your mind, then it will be correct. It has to strike your mind. Ratha, I think you're talking about communications. In communications, please don't expect the noise will be more at the positive side. Sometimes noise will come in the negative side also. Correct? There are different noise will be injected in your channel. So don't think always the noise will come in the top side. The noise can inject in the middle also. It is unpredictable. We call it as noise. Don't go in a short manner that in communication this only will happen. Anything can happen, my friend. Noise can come in the middle. That means it's not only a communication application. It's a general applications also. We have noise levels can enter into the signals. So in general, you think. In general, if it comes like that, how to manage that output? Like that, I'm thinking and designing the circuits. It's not the meaning that by native paper where I have to use. If suppose by chance problem came, then what do you do? That's why these are called possibilities. I'm designing the circuits. So this circuit also we have two possibilities, correct? We have diode on, one case, where we have resistor R, this is VI. Make it on means short circuit we have to do with the ground. This is your output. Output became 0 in the first concept. And diode is off if you take. Diode is off. Resistor R, this is VI. This is open circuit. Output is equal to input we got. So what are the transfer characteristics here? This is VI, this is V naught. We have two lines again here. One line is 0 line and one line is output equal to input line. Output is equal to input line. Where is the break point here? Means this is the break point. For this 0 is the reference, that's why the break point is coming at the origin. So now you have to estimate that when the diode will be on, when the diode will be off. That is a problem will not come for the student because we know the anode cathode positions. Cathode side, if anybody give positive signal, then what happens is cathode is negative, you are giving positive to it. Then the diode will become reverse bias. That is the trick. Cathode is negative, you are giving positive. If cathode is negative, if you give negative, it will become forward bias. So the trick is very easy. Below 0 means negative you are giving. When negative comes here, it will become forward bias. So below 0, we have diode on. Above 0, diode will be off. Previous problems, 3 problems, the diode is on above, diode is off below. But when the diode is reversed like this, automatically the switching conditions are getting reversed. Now you can write it. Diode is on, output is 0, means this line it will follow. This line it will follow. This is output equal to 0. And diode is off, output is equal to input. This line it will follow. So can you see that transfer characteristics has been changed? Correct? The transfer characteristics has been changed. So can I expect the output waveform for this? Output waveform, you can see. This is your output waveform. So what is the simple thing we have to see is, this is a negative side, this is a positive side. Negative, positive. Negative side, no response. A negative side, no response means, can I write the waveform? No. Negative side means this is a negative cycle, no response means 0. This part is 0. Some students are confusing with output waveform. For them again I'm telling. Number of times I'll repeat today. Number of questions I'll repeat the same thing. So if you are a slow study student, your mind is very slow to understand the things. Anywhere it has to start compulsory today. After 4 in the first class, somewhere it has to start your mind. Okay? So this is a waveform. You can see clearly. Negative cycle is this part. Positive cycle is this part. Negative cycle, the diode is on. Output is 0. So output is 0. For positive cycle, if you see, the output and input is coming same. That means your output and input will be same. So I think at least you must be able to understand how I have drawn this graph. So can I say that it is clipping not in the positive side, it is clipping in the negative side. So this response, it is clipping in the negative side. This part is clipped off. So that's why we call this type of circuits as negative clippers we call. previously we have seen positive clippers. Now we are seeing negative clippers in the concept. Negative half is clipper. Very good. So let us complete two more models like this. Let us complete two more models so that first topic will be completed. Let us go for model 5. You do it yourself now, parallel with me. This is R, this is VI, diode, upward and giving. Carefully see, reference battery is positive reference. This is a circuit you can take. Okay, diode is upward. Now let us start doing it. I'll also do it parallel with you. Thus, I think you are not thinking the concept here. Question you are asking very, okay, simple questions they are. Diode on, diode off, how you have taken. You should not ask instantly, immediately. You just see the diagram, start you already. I'll tell you a small trick for it. You can see the trick otherwise. Suppose you have a diode like this. See the trick, you can practice like this. If you have any confusion. Some students who have confusion see the trick. This is ground suppose or positive battery and negative battery कोई भी हो सकते हैं. एक trick बता दूँ देखो for your simplicity. This is cathode and this is anode. First at least you represent like this in the class. First thinking should be like this. Anode means always treated as positive. Cathode means treated as negative. Anode cathode positions. Suppose somebody has given positive signal. Suppose positive signal means positive. So whenever positive is interacting here, the diode will be on. This is the trick. That means if you have the same comparison you are doing, positive is interconnecting. It is called forward bias. Otherwise, if negative is coming, negative you are applying to this point. Negative positive when it comes, diode will be off. So apply this trick, otherwise if you have that type of confusion. Okay, in the next problem what I said, diode is upward, I said. This is anode. Cathode is here. Now cathode sign is negative. Whenever I give suppose negative, have you seen that negative, diode is on. So that is the reason why diode is on in negative side, diode is off in positive side. These are called small sign techniques you can practice. So the confusion will not be there for you. Yeah, Ankum Das, we can say they are working as rectifiers, but only the reference should be 0 volts. If I give positive reference, negative reference, we cannot say they are rectifiers. Rectifiers is nothing but 50% clipping, we call rectifiers. Okay? So I'm expecting thus, I think now it is clear. Use this technique here. Okay? Whenever the same sign interacts, okay, when you are sending a signal to that point, if same sign interacts, we say forward bias. If the opposite sign interacts, we say reverse bias. Like that you practice it. The concept will be easier for you. These are very simple things, so you can develop it. It's not a big issue. So start doing it. Diode is on. Resistor R. There's a VI. There's a short circuit with a negative battery. Sorry, the positive battery. Output is equal to VR is coming here. When diode is off, we have a resistance R. This is VI. And we have open with a positive battery. This is your output. Output is input. We are getting these equations we are getting. Okay? So definitely breakpoint will be there. In every topic breakpoint is compulsory. Where it will come means intersection points. We have to see. This is your input. This is your output. We just draw these lines. One line is a constant line of VR. This line is V naught equal to VR line. And one more line is a 45 degrees line. Output is equal to input line. So can you see the intersection point? This is your breakpoint. This is breakpoint. So with this breakpoint, we can say diode when it will be on, when it will be off. When diode is in upward direction, you can take it as a hobby for you. Always make it as a hobby. Diode will be on always in the negative side. It should be a hobby for you. Diode will be off in the positive side. Compulsory, this is the logic you keep in mind. Whenever diode is in upward direction throughout analog electronics, below the breakpoint it will be on, above the breakpoint it will be off. That conclusion I'll give you the shortcut method for you after this concept. I think there are so many tasks, don't get confused here. So who is asked the question to me? For that person I'm telling, okay? Because I cannot speak the total name because it's far away to me, the laptop, so the names are very small. Letters are, if they are not very clear for me, that is the trouble I'm getting. So who is asked for him I'm telling, okay? The other students don't get confused. So this is about diode on, diode off. When diode is on, output is equal to VR. When diode is on, output will be equal to VR. This is the answer. This is a constant line will come. Up to here, it will maintain the constant line. And above, it will maintain output equal to input means this line. Above, it will maintain this line. So I think you must get the graph like this. This is the graph, okay? So shall I expect the waveform for this? Output waveform, how to write for this? This is your signal. This is your signal for you. I think below VR, this is completely off for you. So can I expect below VR, it is a constant. So you just represent like this. Always write a constant like this. Below means this part is totally stripped off. Only above VR, we are getting output equal to input. So I am expecting the waveform should come like this. This is the waveform. Output is equal to input above the VR. Below the VR, it's a constant line. So this part is skipped off. Okay? This total part is skipped off. So this is the story here. Who has not done, please write. For your sake, I am writing each and every problem. So some students may do mistakes because you are in the earlier stage. No problem. When you are studying something at earlier stage, mistakes happening is good always. So if you have done any mistake, please change it in your notes. Okay? Only one model is remaining. After that, I'll try to give the break for you. Take some break for the breakfast. Then we'll start doing the next analysis. Okay? But first, because first basic class will be slow. Next onward we'll finish off today clippers. At any moment we have to complete now. At any target. So let us last model we'll see. Done. I'm expecting it is done. Last model we'll see. The final one. Model 6. Model 6. Resistor R. This is VI. We have a diode. Upward direction. Having a battery of negative. I am taking. Ideal diode I'm talking. So try to finish this problem yourself. Try to finish this problem. Last model. After this, nobody can design shunt clippers. Shunt clippers can be done in 6 variety of models because diode up 3 models we got, diode down 3 models with 3 references: 0, positive battery, negative battery. 6 models. Please practice it. Done? Great. All the students are telling done. It's a great thing. I'll also do it and I'll stop here. We'll take a break. So just the diode is on. Yes, you can verify your answers. For your reference, I'm drawing again. Whether you have done correct or not, we just see the board. This is one answer. Diode is off. Output equal to input. Okay. The transfer characteristics I draw here. Transfer characteristics. One line is a negative line, constant line. Output is equal to minus VR. Another line is a 45 degrees line. Output equal to input. Like this, we are getting 2 lines. We have some intersection point here. At this position, we have some intersection point. Correct? Between the 2 lines, we have the intersection point. This is the intersection point we have. Break point, we can say. So we have some break point here as minus VR. This is the break point. So below this break point, diode will be on. Above that break point, diode will be off because it is in upward direction. Have that logic. Correct? Directly, diode will be on this side. Diode will be on this side. Diode will be off this side. Okay? On will be reverse, you have right. On will be in the below minus VR. Off will be on the side. So can I expect on means it's a constant. So maybe this is the line we'll get. This line will come below minus VR. Output equal to minus VR. Above we are getting output equal to input. This line. So your transfer characteristics will be like this. That means the signal is going to keep it up below minus VR. Above it is trying to pass the information. That is the meaning. Okay? Okay, Vinay Kumar. I'm giving half an hour break for you. Take rest for half an hour. If eyes are paining for you in the mobile. After half an hour, we'll start the class again. Okay? Half an hour I'm giving time for break. For your breakfast. No worries. So what will be the answer here? Waveform you can write output waveform. This is your output waveform. This is your output waveform. Can I expect below minus VR it's a constant. Below minus VR is a constant. Above it is passing. So above it is passing up to minus VR. After that it became constant. Maybe you'll get the waveform like this. So I'm expecting these are the results for your first topic called shunt clippers. Okay, in the break time you can see wherever you have small doubts, please rectify the doubts. Otherwise in the next it will get affected for you. Because who knows shunt clippers? Designing series clippers is not a tough for us. Because same results will come. They'll always opposite to the shunt. So we'll do fast in the next lecture. Okay. After that we'll go to 2 independent level. After that 2 more modules. So today we'll close the clipper topic. Okay. So take a break for half an hour. Breakfast you can take nicely. By 10 o'clock I'll start. 10 to 12:30 or 12:45 I'll stop the class for you. Okay. At a stage we'll complete the remaining clipper topics. First shunt is completed. So you can take a break 9:30 to 10. You can take a break. Okay, take half an hour break. After the break, we'll try to complete the remaining issues. Okay, I'm leaving for half an hour. By 10 o'clock, we'll continue.